Hello, welcome to episode number 2 of the tutorial on dynamic and mechanics. So we are picking equations of what motion from the outlines we mentioned in episode 1. This is the second outline. So what are the equations of what motions that we are going to be making use of? We are to state it and use it in solving questions. This episode will only state those equations, then the subsequent ones we use to solve various questions. So we have to consider a body which is starting with an initial velocity u and moving with what? A constant acceleration a for a time t at an end of which it attains a velocity of what? V. So this is the final velocity initial after covering a distance x. So by definition, we can say that acceleration is what? Change in velocity over what? Time taken. So picking it from here, we can say that our acceleration, which is a, is equals to the change in the velocity between final and initial will be v minus u out of what? Time taken. So this is what we can be able to get from here. Now, if this is what we have, this is showing an equation, because this is also an equation but in a word form, but this is showing the equations of what we can do. So what do we do from here? Let's rearrange this. If I rearrange this, I'm going to, can I just let me buy space from here? I can cross multiply here, where a and t will multiply equals to v minus u equals to what? At. And if I maintain the v here equals to, sending this away, become u plus what? At. This gives us the first equation of what? Motion. So in this equation, whenever we are asked to find the final velocity, whereby initial velocity, the acceleration and time of the body is provided, then we go for this equation. This is the equation we are going to be making use of. Any question that demands you to find either initial velocity or final velocity, when the time and the acceleration is given, or any of them is being asked to find when the remaining three is provided, then this equation is going to work. Then let's also look at make use of velocity. So let's say we have average velocity, which is also equals to the total displacement over total time. So I can say that the total displacement divided by the total time, the time taken. So if that is the case, I can easily say that v as a velocity equals to displacement. I think we have displacement, the distance covered. So we are going to have that as what? S divided by what? T. So let's label this as equation A, since we are just making use of that. Now, if the body is moving with what? A constant velocity. So quoting from here, if the body is moving with a constant acceleration, not velocity, if it is moving with a constant acceleration, then our average velocity now is going to be the final velocity plus initial velocity divided by 2, or initial plus final divided by 2, if you are using a constant acceleration. So this is the average velocity. This is also average velocity. So we can easily equate. Can I have this? Let's say if this is our equation B. So equating the equation A and B together, I can say that both are going to be, I think this is velocity, right? So what do? We are going to have the S divided by T equals to V plus U divided by what? 2. Then here, let's concentrate on the displacement, the distance covered, which is in the direction. So we multiply both sides of the equation by T, and that gives rise to, let me cap it here, that will give rise to S equals to V plus U divided by 2 multiplied by the time. So if I multiply by the time, I'll be having the distance. Remember, the distance or the displacement is just the velocity times what? Time. So the average velocity times time. So this is also giving us, let's say we label this as equation C. We have A, B. So let's say we have our equation what? C here. Now, what do? We can also express T. Let's say if we have from equation 1, can I have T, okay, from equation 1? From equation 1, which is here, I'm going to pick it from here. If I have this, I can also find T in terms of VUA, whereby as I have this, if I cross multiply, the T will go here, the A will come here. So I can also have T, let me indicate here first as V equals to U plus what? AT. That implies that our T is going to be equals to V minus U divided by what? A. So now, if this is substituted into the equation C, we can say that let's say put this T into equation C, and I have the space there. I can have S equals to still V plus U divided by 2 multiplied by V minus U divided by what? A. So we want to express this, the T here, so that we can substitute. So what do? Let's clear here. So right from here, we can have our S equals to, the numerators are going to multiply since the two separate fractions. Numerators together, the denominators together. But if you check, VU plus minus, that will give you difference of 2 squared. So I can say that it's the same as V squared minus U squared, then 2 times A. That will give us what? 2A. In this case, let's rebrand. Since we already know, we express the first one in terms of V, in terms of S. Let's now go in terms of this. So if we cross multiply, what am I going to have? I'll be having V squared minus U squared equals to 2AS. This is multiplying this. But I'm going to move this in to have V squared equals to U squared plus what? 2AS. And this gives us the second equation. Here, we use this when velocity, final, initial velocity, and acceleration and displacement or distance are provided. No time. You see here, we have velocity, 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 acceleration, time. And here, distance. Time is not there. So we go for this. Alright, don't forget that this is also used in getting to this. So we can also manipulate this the way we have done this to solve any question that demand this formula. Okay, so what do we do now? Let's see. We have the first two. Let's move on to from equation 1, which is V equals to U plus AT, right here. Let's say we substitute into equation C, right here. I'm replacing the V, meaning your distance will be still equals to U, which is now, V, which is now U plus AT plus U, still divided by what? 2, right here. Then T will now what? Multiply. So right from here, this is the equation C that we are putting equation 1 into. So this T remain, all this go. You can see U. So I can have S equals to 2U plus AT. Can I multiply it once? Okay, let me count down. 2, then multiply still by what? T. So this T can only multiply the numerators. So I can have my S equals to this times this become 2UT, then plus what we have here, at squared, all divided by what? 2. And this is a 2 fraction divided by 2 is the same as s equals to dividing the whole of this by 2 give you ut, dividing the whole of this become 1 over 2 at1 squared. That gives us what? The 3 equations. So therefore, the 3 equations of motion become this, this, and this. Now, each of them can be used based on the type of information provided in the question. So if we are here, these are the information you need: final velocity, initial velocity, acceleration, and displacement or distance. Then the displacement, if you are looking for displacement, the distance, and the initial velocity, time, and acceleration are provided, you go for this. You're looking for any of the information here: final, initial, acceleration, and time, provided the 3 of them are provided. So these are the 3 equations that will be needed. So proving them just like we did is also good because some lead to the other. So if in case I cannot remember this and I remember this, if I find all the information available, I can equate and come to this place. Alright, so the next episode, we will be taking questions that will demand any of these being used, whether a combination of them or just separate, and see how we can apply them in solving questions. Don't forget to come back to the space for more episodes for more videos of this kind as we take the journey into mechanic dynamics.